Good evening. I'm Rich Shriver, a member of the Board of Directors of the Watershed Fund. We're here with the Old Lyme Conservation Commission and Estuary magazine, and would like to thank you for joining us this first and hopefully many quarterly Connecticut River watershed seminars. These seminars are for anyone interested in the environment, focusing on the past, present, and future of the Connecticut River watershed, from the northern reaches of New Hampshire and Vermont, flowing 410 miles south to Old Saybrook and Long Island Sound, and the issues the watershed faces. The seminars are given by experts in their fields, providing in-depth, accessible, and timely explanations of the river's history, terrestrial habitats, aquatic habitats, invasive plants, geology, and restoration efforts. 4 seminars are planned for 2026, starting tonight with water quality. In April, bird habitats. In July, building resilient habitats. And in October, aquatic or fish habitats. Seminars are open to the public, and your registration for the seminar tonight will also include registration for future seminars. A recording of the seminars will also be available for public access. You will be provided a link to the recording in the coming days. With time permitting, we may be able to entertain some questions and answers. So welcome and thank you for your interest in an important natural resource. We try to cover many of the salient issues of the watershed between the covers of Estuary magazine and are always interested in hearing how we can better serve our community. Now, I would like to introduce Dr. Andrew Fisk, Northeast Regional Manager, American Rivers. Andy has worked in conservation across New England for over 25 years, in roles across Maine state government and as executive director of the Connecticut River Conservancy. He is energized by working with local communities to find environmental problems and fix them so that everyone can be sustained by the benefits of nature. Andy has a PhD in environmental sciences from Rutgers University, and his favorite river, surprise, is New England's 410-mile-long tidal river, the Connecticut, with its current name taken from Mohegan and Nipmuc origins. Dr. Andy Fisk, what do we know about the quality of our water of our river?
Thank you, Rich. And the Watershed Fund, the Old Lyme Conservation Commission, and certainly Estuary magazine. Let me share screen and we're going to get started. Good evening, and thank you everybody for coming out. Again, I just want to note really great appreciation to the Watershed Fund and Estuary magazine. However you've heard about the seminar tonight, please do follow along Estuary magazine. It is a tremendous resource, and we are really grateful for the way it communicates and provides opportunities to talk about all aspects of life within the Connecticut River watershed. So shout out to Estuary and the Watershed Fund. So tonight we're going to talk about the water quality of the Connecticut River. I'm here in my role with American Rivers. We're a national organization. We have been around for 50 years. We work across the country, from the headwaters to the ocean, and my responsibility is the Northeast region in order to find the resources and the people to do good work in 5 core areas. And I'm really honored to be in this role here and also to continue to talk about, yes, my favorite river, the Connecticut. When we're talking about water quality and rivers and water, it's really important let's go back to the basics and recall the public trust doctrine. It's very important to know that the rivers and waters and streams and wetlands and lakes and all the things that live in them are commonly held resources. And so the public trust law provides all of us a meaningful role in saying, what do we want for our rivers? What are the goals that we can set for them? What are our aspirations, and what should they be doing for us, our communities, and all the critters that live in them? So we have a very, very, very important seat at this table. And for the decades and decades and decades that people have spoken up on behalf of those rivers, a huge shout out to them in recognition of the public trust doctrine. So in New England, we're incredibly fortunate. We have been working on this issue for a very, very, very long time. And I think it's important to note that let's go back to 1947, 1948. That's when the federal legislation, the federal government began enacting authority to the states to start acting not only among themselves, but in coordination with their neighbors. And I want to give a shout out to the New England Interstate Water Pollution Control Commission, or that NUIPIC. In this image you see here on the right, that's the Connecticut River. It is not the only river within the jurisdiction of the New England Interstate, but it definitely recognized that if we're going to start addressing questions of how we make our rivers cleaner, healthier, and our communities stronger, we can't just be thinking about state boundaries. And so beginning in the 1940s, we attempted to erase state boundaries for purposes of addressing a watershed, because a artificial political boundary is not the best way to think about water quality and its health. The New England Interstate Water Pollution Control Commission still exists and does a tremendous amount of work not only in water quality, but in restoration, community engagement across all of the New England states and New York these days. It's also important to note that we here in New England have been fighting for cleaner rivers for a very, very long time. And I'm going to give a shout out here to the Connecticut River Conservancy, my prior organization. This is an image of Dr. Davidson and his wife from 1952, when he spent time traveling the entire length of the watershed and documenting the challenges that the river faced back then in 1952. This is an image of he and his wife noting that the water quality, I believe this was taken in Brattleboro, Vermont, was not something that was visually or environmentally appealing. So people have been saying we can do better and we deserve better for both the people, the communities, and everything that lives in our rivers. This question of water quality really turns on 1972 and the revisions to the Federal Water Pollution Control Act, or what we now call the Clean Water Act in 1972. And so another really important thing to think about, not just the public trust doctrine that we all own and commonly share these resources, but what does the Clean Water Act seek to do? And this is where I asked you to remember the Holy Trinity, right? And so the beginning of the Clean Water Act, its objective is to restore and maintain the chemical, physical, and biological integrity of the nation's waters. Chemical, physical, and biological integrity of the nation's waters. And in 1972, I would argue, when you look at the congressional intent and the politicians and the scientists that set out this ambitious law, they weren't sure that it would work. We didn't know that if we endeavored to put more investment in terms of brain and technology and heart and passion, would our rivers come back? And I think we all know they have. And we should be incredibly proud of the advocacy starting back in the middle of the 20th century that then put legislation in place that had real teeth. It provided the public a meaningful place at the table and allowed us to articulate the goals and to do it in a way that would make rivers healthy in all aspects. So let's talk a little bit about how you do this before we start talking about what the current status of our rivers are. So when you're thinking about water quality and the Clean Water Act, the first thing you have to do is establish, what do you want to use these rivers for? And it's important to note that this effort is frankly very anthropocentric, right? And so we're deciding, what do we want to do or use from our rivers? And so the law sets out national uses of our waters. Fishing, swimming, we want to use them for drinking water. We want to use them for cooling water, irrigation. This is important to note because before the Clean Water Act, we actually had in law that you could use a river to treat pollution. That is gone, right? And so we fundamentally changed one of the really important uses of rivers, which was the place to dump everything and let the river do all the treatment and let the river try and clean up our mess. That is gone, right? And so there's limited uses that we have defined. Well, then the next thing you want to do is, well, how do we govern those uses, right? If we say that we want to swim and fish and drink our rivers, well, you have to set standards. And so the Clean Water Act put a lot more muscle into the standards that here in New England existed back in the 1940s. So for a long time here in New England, particularly, we've said, these are the uses for our rivers. Yes, we said allow them to treat pollution, right? That's gone in 1972. And then we've said, here's the numbers and the words that are going to equal a clean and healthy river. And so it's important to know that we're thinking about water quality standards that define uses that are largely human-centered. And those standards are based in numbers and words. And I've given you a few examples here. Milligrams per liter, right? That's a chemical standard. Dissolved oxygen is measured in milligrams per liter. That's a chemical parameter. And so we are saying that a clean river has to have a certain amount of oxygen in order to support the fish that we want to catch, for example. We also say things like, we don't want stuff floating around on top of the rivers. And so we have narrative standards that say things like, very simply, there shouldn't be scum, there shouldn't be trash and debris in our rivers, kind of basic. And then we start having standards that say our rivers should be fishable and swimmable, right? And fishable and swimmable now is starting to get to the point where we have to think in a much more sophisticated way, and we have to compiling many, many, many more standards in order to say all of the fish that we care about and all the places that we want to be in that river need to have all of these different chemical parameters, physical characteristics associated with them, that when you measure them all, it meets those human uses and those aquatic uses. I want you to make a transition with me, because what I'm describing is sort of the basic way that we implemented the Clean Water Act and thought about uses and thought about standards. Fundamentally human-centric at first, but we then walked into this fishable, swimmable criteria, right? Well, that started begging a whole lot more questions that moved beyond a simple measure of a chemical concentration or some other physical characteristic of that river. So, pardon, I advance. All right. So here's what I want to do is take a transition briefly and walk you into the way that water quality is being thought of now over the last, let's say, 30 years. So often we think about the Connecticut River and we think about those days when we were trying to restore Atlantic salmon. Often people take that idea of a clean and healthy river and they associate it with a charismatic fish. And so for decades, we spent a lot of really important time and resources and expertise thinking, if we focus on the Atlantic salmon as a top predator, charismatic species, lots of people like to fish for them. They are a good food source. They're a dramatic sport fish. If we paid attention to that top predator, then everything would be okay. There's a theory of ecological restoration. When you think about a grizzly bear, if you protect lots of land for that grizzly bear to wander around, lots of other species will benefit. There was a thinking that if we worked to protect salmon, we'd be driving towards that fishable standard in a really great way, and all the other critters would come along. I'd like you to disabuse this great affection for Atlantic salmon and the Connecticut River, and frankly, other rivers. And I'd like you to pay attention to the little guys. I'd like you to start thinking about the diatoms and the algae in Cimbella vulgata. It is a genus and species of diatom. It's really tiny. It's an algae. And so they are able to, when we listen to them, they're able to tell us very important things about water quality. And you also need to listen to the bugs or benthic macroinvertebrates, and this is the caddisfly. What's going on? We recognized probably 30 years ago that simple chemical measurements or simple physical measurements were not telling us enough about what a truly healthy, fishable, swimmable river would be. And we started thinking, how do we understand how water quality should behave and be? And so I introduce you here to a very simple model. You understand this intuitively. This illustrates where you have natural conditions and very little human disturbance, you have a very high ecological condition. You know this. High up in the watershed, very little people, you have very pristine water. The more you increase human disturbance, pavement and roads and the like, your ecological condition will degrade. And that's that line showing a degrading ecological condition as you have more increasing human disturbance. The way we thought about water quality systematically for a long time was we drew this blue line, and that blue line was fishable and swimmable. Everything above that condition, we said was fishable and swimmable. Everything below that line was a fail. Well, so what? Pass fail. For too long, we had a water quality system that allowed for a lot of ecological change. Before we got more sophisticated in understanding and measuring water quality by listening to the diatoms and the bugs, we were able to have pristine conditions gradually degrade until they hit that very simple pass-fail formula, right? So we were not implementing the Clean Water Act, which said when you have high-quality water, you cannot let it degrade. So for decades, we were letting water degrade, death by 1,000 cuts, right? And so the biologists came forward and said, we need a better way. And so what I want to do is show you very quickly what the biologists did. I want you to now imagine you're in the upper watershed in a pristine ecological condition, and a biologist goes out and samples the bugs. They put a little rock basket in that stream, they leave it there for a while, and they come back to the lab and they count those bugs. I want you to pay attention to the blue, green, and red circles. The blue circle are those bugs that are very sensitive, right? They don't like a lot of ecological impact. The bugs in the green circle, they're a little tougher, they're more tolerant. The bugs in the red, they can take any kind of condition, right? Bring it on. They can live in all manner of ecological condition. And so when you sample, you see this distribution between sensitive, moderate, and very rough or tolerant species. And you take these samples lots of places and you collect the data, and then you go a little bit farther down the watershed, and you're now in a location that's really nice, but it's in the watershed in a place that has more human activity, potential agriculture. There's a little bit upstream, and you sample, and what happens here? You see those sensitive critters in the blue. You see those moderate creatures in the green, and then you see some in the red. And the relative distribution is similar to that place upstream. But what do you see? You see many, many, many more of those individuals. You see a lot of abundance. Well, what does that tell you? It tells you that there's more food in that stream and there's more nutrients, for example. And so you're seeing a change in ecological condition because the distribution and type of those bugs is illustrating an ecological condition that you want to protect, right? And so now you're creating gradations in that pass-fail system. And then if you go all the way down to here in a culvert below the highway, you take that sample, there are no sensitive bugs. You see some of the tolerant, but it is dominated by those critters that can take any kind of condition. And this is an illustration of a failed condition. Now let's put that back on the model, right? And so what you now see in terms of water quality and how we are setting goals and how we are seeking to maintain conditions and improve them is we have no longer pass-fail in school, but you have AA, A, B, and C, and those are characteristics or classifications of stream segments. And then you see fail. And when you have a water body that is within that A band, it has only a small departure in ecological condition that is allowed by law, right? And so you're protecting a condition and not letting it drop farther and farther down, right? That is a dramatic improvement in how water quality protection and state and federal programs have transitioned over the last 30 years. And it's because we have listened to the bugs and the diatoms, and the statistical models have produced this ability to protect water quality once we have it at a level, and then to point upward to where we think it could go. Okay, how do we know what's going on in our waters? The Clean Water Act says that states every 3 years, they got to tell us, right? And so they have to take all of their water and tell us where it is and what it is, and then be able to assess whether it is meeting those standards that have been applied to it based on the policy and regulations and law that we have administered. Every 3 years, you will see this integrated report from each of the states in the US. It's important to note that the Federal Clean Water Act has said to the states, the water quality standards and classifications are yours. It is a state prerogative and a state authority to do this under a federal law. So the states have a huge role, as do our residents and citizens who participate. Okay, what causes pollution or harm to rivers? You guys know this. It is straightforward. Untreated sewage, treated sewage. We are seeing now, and we'll talk a little bit later about some of the constituents in treated sewage that our treatment plants are not designed to get rid of or mitigate. Road and parking lot runoff. Road and parking lot runoff, soil and sediment from fields, rainfall, that is now the largest contributor to water quality impairments in the watershed, right? It is not effluent from treatment plants any longer. It is all of that that's coming from many, many places across the landscape. That is the place that we need to address now, since we have spent decades building an infrastructure of wastewater treatment plants and also dams. Let's dive in. It's important to know when you're looking at water quality, it's not as simple as clean or dirty. We're not going to go through this whole table, but what I want you to understand here is when we are looking at measurements of water quality and health of a river segment, you can say it's really bad, it's just over the edge bad, it's maybe bad, we don't have a lot of data, and other ways on the positive side, likely good, marginal, and absolutely good. And so that's that gradation of what we know about the status based on information or lack of information. And then on the categories, it's important to note that when we say there's a problem, we also have to say, is that a problem that came from nature? Is it a problem that we can solve one way? Or is it a problem we have to solve another way? Or is it a problem we say we've solved by a plan, even though the water quality is bad? And that's an obligation of the states when they say, here's your water, here's the status, and where there's problems, we are obligated to fix them, right? And so there's these categories, and you can see bad water quality that can stay that way for a very long time, because the plan, even though it's in effect, hasn't actually been implemented for any range of understandable reasons. Money, politics, lack of attention. Let's start going into some of the examples. And again, water quality parameters, there are hundreds of them. We're talking 4 states. It's very difficult to be comprehensive. So I'm pulling some examples of water quality trends. Many of these exist around the watershed, but we're taking them from different reports produced by the states. And so the Connecticut River in New Hampshire, pH. It is an impairment along the main stem of the Connecticut River for most of the length in New Hampshire. The state of New Hampshire has said we need our water to between 6.5 pH units and 8. And so what we're seeing is there's any number of locations where the water is too acidic. Why is that? Atmospheric deposition, maybe some geology. And frankly, we may see instances where there is a natural basis for a low pH, but a standard was set and not necessarily understood some of the natural conditions. You will see that frequently in water quality standards with things like arsenic or some of the radioactive elements that you see in groundwater. pH is generally stable these days across the watershed. Why is that? Clean Air Act. And we have started to regulate those atmospheric depositions that were acidifying our lakes. But in instances throughout the watershed, it is still perceived as too low and damaging to aquatic life. The other way you can look at water quality standards is aggregating miles and acres. And so here's some stats from New Hampshire. They have 17,000 miles of river and about 180,000 acres of lakes, right? So that's the total amount. 2,600 of those 17,000 are impaired by stormwater. It's that rainfall again. It's the parking lots putting pollutants into our rivers. The other part of impairments that are coming from the atmosphere and rainfall are nutrients, right? And so we are seeing that 824 miles, for example, and 48,000 acres of lakes are impaired by nutrient factors. That's the whole state of New Hampshire. Sometimes this data is difficult to talk about within a watershed, right? So that's the entire state of New Hampshire. But you're seeing a lot of mileage and a lot of acreage impacted by stormwater and rainfall, and nutrients in many of those systems are accumulating to harmful levels. Well, if you really want to geek out, it's really important to know that states now, because of databases and computer technology, you can DIY, right? All of the states have viewers where they have geographically based systems, because every water quality segment and lake has a database ID in a federal system, and all of those segments are required to have a designation in terms of the status of their impairment for all of the standards that apply to them, right? And so you can go online, you can click on segments. If that box there, you can see trends over time and go very, very, very deep, right? So this is publicly available information. And if it's just FYI and curiosity, great. It is also an incredibly important tool for advocacy to make sure that we are holding those responsible to the standards that we have set. Again, atmospheric deposition, right? A lot of these issues are not coming from a specifically defined point or pipe. Mercury. Mercury has been listed as an impairment on many, many, many river miles and lakes. Where's it come from? Mercury comes from the burning of fossil fuels, and it comes from the burning of fossil fuels, not just in Bow, New Hampshire at the coal-fired power plant there, but throughout the Midwest and the country. And so the New England states back in the early 2000s were confronted with all of these impairments and a legal requirement to fix the problem. Well, how do you do that when the source of the pollution is many, many miles away? And that's not the only source. You have your own in your own state, but a majority of that problem was elsewhere. The New England states got together and said, we're going to actually create a regional cleanup plan that identifies upwind states and upwind sources. And we're going to look to the EPA to say, you need to be able to set national standards on mercury so that our rivers that are downwind from these sources will eventually be equal to allowing us to eat those fish and be that fishable standard. It's not really worked. We still have a tremendous amount of mercury impairments because we are still burning fossil fuels, and there is enough mercury in the environment that many consumption advisories still exist. But that's this idea in terms of water quality. You may need to address it in not just a state or regional way, but a national way, and grab requirements in other laws. The Clean Air Act can have a tremendous amount of importance to acidification problems in our lakes and also reducing mercury impairments. Connecticut River in Vermont, salt, right? Road salt. Road salt is an increasing problem, and we are measuring for that in a couple of different ways. And this data from Vermont is showing you different levels of chloride concentrations, and we're actually measuring chloride, not sodium. And so what we know is that the state of Vermont has said this number of 860 milligrams per liter, that's like a really lot and really, really bad. And you can see some of those red dots. When you look along the Connecticut River, you're seeing that a number of those points are actually in that chronic level, or that 230 milligrams per liter. Well, so what? Like, what does that mean? Well, we know when you talk to aquatic biologists that 50 milligrams per liter actually is a threshold at which those bugs have a real problem, right? And so what we're faced with some of these very diffuse pollutants, setting the standard, how do we do that relative to some of these concentrations that we're seeing? And what do we do to address it in terms of road salt application by our DOTs and roads? It is a very, very significant problem. And in terms of context further, if you to go into an upper watershed and measure those concentrations in a forested, undisturbed watershed, you would see chloride concentrations about less than 2 milligrams per liter, right? So these are very, very, very dramatic impacts that are having significant impacts on aquatic life. Still in Vermont, what this image is illustrating to you, and again, so this is talking about lakes and ponds. When we're looking at water quality now, we're not just looking at a individual chemical or physical or biological parameter. We're actually trying to assess the habitat in terms of the upland and what's actually happening inside the lake in terms of nutrient concentration, invasive species, and in this case, mercury deposition. So this 4-quadrant assessment is showing how these characteristics, nutrients, shoreland and lake habitat, invasive species, and atmospheric deposition all kind of relate. Let's aggregate these parameters and make an assessment as far as how they're being attained in each of these water bodies. They don't all interrelate, but it's this idea of let's be more synthetic in these assessments to give us a more complete picture, at least in one place. You can see in Vermont, this is the Deerfield and Lower Connecticut Basin. These lakes and ponds are actually doing pretty well, but there are some instances, particularly of mercury deposition, where it's pretty bad, and those would have consumption advisories. Cyanobacteria. Again, this is information from Vermont, but you see cyanobacteria or algae blooms happening more frequently in lakes and ponds and also impoundments behind dams. Cyanobacteria are a class of blue-green algae. They are photosynthetic. Amongst those cyanobacteria species are some that actually produce toxins that are harmful to animals and humans. Dogs that have swum in cyanobacteria blooms with those right species with those toxins can get very ill, as can humans. And what we are seeing because of nutrient inputs from roads and lawns and agricultural operations, increasing number of these blooms that are observed over time, and more of those blooms are demonstrating toxins, which are hazardous to animals and people's health. Forever chemicals. Another diffuse and distributed problem. Forever chemicals are what you may hear as PFAS or firefighting foams, or those chemicals that are in nonstick cookware and also in our clothing. These forever chemicals have been widely used, manufactured for decades and decades, and are now all over the landscape and are throughout our bodies. And so what we found, particularly in Vermont, is manufacturing facilities and landfills have been contaminating groundwater and introducing levels of these PFASs that are hazardous to humans and have caused a significant concern. What's happening with these point sources or waste sites where PFAS was manufactured or stored or used extensively, like at airports? What's happening to water quality both in groundwater and surface waters? And so in Vermont, they found that 17 public water supplies have been contaminated at levels above this 20 parts per trillion, a very, very, very small amount, which has been demonstrated to be an adverse human impact. The state then said, well, what about our surface waters? And went out and in Vermont, and we're doing this in other places, looked at surface water sources in areas where they thought might be impacted by these prior manufacturing facilities or dumps or landfills. And in general, they have found that the levels in the surface water sources are far below this 20 ppt level, which is slightly encouraging. But the forever chemical issue in the environment is very, very problematic. As a tangent to our discussion tonight, you may have followed this issue in the state of Maine. Biosolids from wastewater treatment plants have been used as fertilizer on agricultural fields all over the country. In Maine, they found that There was so much of these forever chemicals and the biosolids that organic farms were actually contaminated and needed to be closed down. They could no longer have their meat that grazed on those fields sold because of the levels of those forever chemicals that were consumed by the cows on the grass, fertilized by those biosolids. So PFAS is not only a question of, or forever chemicals, of monitoring for it, but how do we get it out of our production system and stop putting it into the environment? This is a really great example for why we need to think differently about some of these contaminants. So if these contaminants are coming into a wastewater treatment plant can't treat that. They weren't designed to be able to break down those compounds. And so the wastewater treatment plants, we have to figure out what's their responsibility, what's the broader public responsibility, what's the manufacturer's responsibility for this. And we can't just say that municipalities, you have to fix this. We didn't create treatment systems to solve this water quality problem. And so it requires a different way of thinking about solutions. The Connecticut River in Massachusetts, some of the other impairments, hydropower dams, we'll talk about that briefly. Invasive plants. If there are invasive plants in a river segment or a lake, it violates the Clean Water Act. We are seeing exceedances of temperature standards because of climate change and also alterations in hydrology and flow. Waters are getting warmer and violating standards that we have set for them. And yes, we are still seeing water quality segments that violate the law based on trash and odor. I had hoped we would be long past that, but alas, we are not. Let me talk a little bit about how hydropower dams can violate the Clean Water Act and create a water quality impairment. What I want you to do is look at this hydrograph, and what this is the heartbeat of a river. And I want you to imagine standing next to this stream that has no dam on it every day of the year from January to January. And you're watching that water flow by on this logarithmic chart. And you all know this. The river flows higher in the spring and it drops back down and it goes back up. And there's a natural rhythm or heartbeat to that stream. When you introduce a dam, what happens to that heartbeat or that hydrograph? You can say that that heartbeat starts getting a very regular but very problematic beat and rhythm. What you're seeing here is that hydropower dam is holding water behind the dam and releasing it through the turbines, holding water behind the dam and releasing it through the turbines. And so as you're standing by this stream below that dam, every day you are seeing that river rise very high and then drop back down and rise very high and drop back down within the space of hours or days. And what that does is physically damage aquatic habitat, dries out aquatic habitat, washes away critters that are reliant on a less turbulent and erratic flow. And so you will see violations of river segments that are based on hydro modification. And so we do have standards that say the flow of water shall be such that it doesn't mess up aquatic habitat. Let's go a little bit farther downstream into the Connecticut River in Connecticut and talk about Long Island Sound. Long Island Sound is a tremendous success story. The Connecticut River provides 70% of the fresh water going into Long Island Sound. We've all known that for decades, as a result of increased nitrogen, we have had dramatically diminished dissolved oxygen, and Long Island Sound was, a majority of Long Island Sound was declared dead. There was zero or very, very low dissolved oxygen because we put too much nutrients into that system because we were not treating our municipal and industrial waste sufficiently. We've done an amazing job to be able to put more controls on plants, make those plants much more sophisticated. And over decades, we are seeing now that there are very, very small areas in Long Island Sound to the west that have low dissolved oxygen for periods of time. But the majority of Long Island Sound now, trends continue to increase. We are seeing more dissolved oxygen, and we think that's a good thing. Well, we're actually changing the outcome for Long Island Sound. And it goes back to that biological definition of what a healthy water should be. We now know that if we are only seeking to improve dissolved oxygen, we are not benefiting the entire ecosystem function. And so what we have done here in the Long Island Sound Cleanup Plan, which is subject legally to the states of Connecticut and New York, it needs to touch Massachusetts, Vermont, and New Hampshire, but it doesn't legally. We have now said that we're doing great on dissolved oxygen. Now what we want to see is increased coverage of eelgrass. We want to see a biological outcome because the eelgrass is the signal species or signal critter in this case that's pulling along all the other ecosystem values. This is tremendously challenging from an intellectual, scientific, and regulatory perspective, but we are doing this type of transition around New England, Long Island Sound, Great Bay, and New Hampshire, and other places, drive to a ecological endpoint or a biological endpoint, not just a chemical one. Wrapping up here. So for a long time, we've been measuring parameter after parameter after parameter in place by place by place by place. And so the biologists are now recognizing, well, you know what? We can start finding surrogates that will tell us over a large area what's going on with water quality. You know what the best predictor is? Pavement or impervious surface. So over the last 20 years, we've been able to say, when you have a watershed, a pretty small one, right? Maybe 50, 70, a couple hundred acres, and you go in there and you look at the bugs and listen to the bugs, what are they telling me? You can collect enough of this data and find a percentage of impervious surface in this smaller watershed below which you know you're going to meet those fishable and swimmable standards, which translates to protection of aquatic life, to use the term. Above that, you are always going to have violation of standards. And so now you have in this image of the right in the state of Connecticut, when you map impervious cover in polygons where it is larger than 12%, the size of those small watersheds, you have violated water quality standards, and you can make a broad-based assessment and then go directly to solving the problem. Because for a long time, we were spending a lot of effort monitoring, trying to find the problems. It's now time to have more sophisticated tools to show us where the problems are and drive quicker to those solutions. Solutions here is green infrastructure and stormwater best management practices and how we develop on the landscape. Another point to bear in mind, apropos of these surrogates where you can remotely understand what is the water quality, is to know we can't measure them all, right? And so what this is here is a chart from a Connecticut report about the status of their waters, and it's telling you how many miles or acres we actually were able to assess or not assess. And so it's important to know in these every 3-year reports, based on capacity or other limitations, we may not have information. And there are a lot of segments out there where we just don't know what's going on. And it's a valid reason, capacity, staffing, and a lot of water and a lot of parameters, but it's important to follow that along and understand where don't we have information. Well, that leads me to a very, 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 very important point: volunteer or community science, right? State agencies and nonprofits for decades have realized that the public can gather valid information on which people can make decisions. And I'm showing you here an image from the website, Is It Clean? Again, this is from the Connecticut River Conservancy. The Connecticut River Conservancy, as well as many other organizations, have assembled volunteers, taught those volunteers how to collect information, and taken that information and presented it to the public, presented it to the regulatory agencies, and said, this is information you can make decisions on. What is this information? All of these point locations are places where volunteers have collected bacteria information, and allowed you as a user of the river to decide, am I going to go boating or swimming based on this information? Blue, it's great. Yellow, I want to be careful. Red, you should probably stay out of the river. So the public has an opportunity to not only say, what do I want my rivers to be? The public can actually provide valid information that decision makers can use. This bacteria information then can go to the state agencies and they can say, we understand there's a real problem here. It's valid data. And now we can actually take action to fix it. There are any number of volunteer or community science opportunities that you as interested folks can participate in. But it's important to know that this is not just an idle exercise. It is a valid and important part of the team that is saying, how are we doing and what are we going to do to fix the problems when we find them? So a quick tour around water quality and the Clean Water Act in the Connecticut River watershed. What do we leave with from tonight? The Clean Water Act, we didn't know if it would work. It did. Water quality comes back dramatically quickly. We know now that there are many, many ways to define healthy water. And often as not, if we listen to the critters that live in those waters, we're going to get a better and stronger answer for what that water quality should be. We have spent billions and billions and billions of dollars on our wastewater infrastructure. It has done a remarkable job. We have done amazing work to turn our rivers from gross and horrible to disgusting to really wonderful and dramatic places that we can enjoy in many, many different ways. There are many problems still confronting us, and often as not, they are not related to the stuff that's coming out of a pipe from a municipal wastewater treatment plant. They certainly need to do better. We need to advance that technology. But as that cartoon character Pogo that many of you may know, the problem is still us. And so there's a tremendous amount of personal responsibility to understand how we develop on the landscape and how we ourselves mitigate the challenges that we are putting on our rivers. And I'll leave you with this photo from Al Braden. This is the Connecticut River in Vermont near Fairleigh. And this is an image that says to me, well done. And what we now need to do for the next generation, which is part of the future seminar series, is make these clean and healthy rivers full of life, people, and fish. As you will see later in the seminar series, our rivers do not support the amount of life that they used to. And now that we have cleaned them up, our job is to do more and different things to ensure that there are millions and millions and millions of fish ascending from Old Saybrook all the way up to Pittsburgh. So thank you for your attention tonight. Happy to answer any questions. And thank you for caring and participating in making your rivers happier and healthier.
Andy, thank you so much. What a wonderful presentation you have, and great information. There were a couple questions that came up during your presentation. Are you able to see these questions, or would you like me to read them off and respond?
Why don't you grab a few? That's probably
Okay. Well, I've got a
find
question.
some tough ones. Find some tough ones.
Oh, some tough ones. Okay. Well, I'm going to start off with Alicia Briley, who asked, hi, if the dams are affecting clean water quality, why do they still exist? Have you all connected the indigenous tribal communities in Connecticut so they can share their thoughts with clean water?
There's many things in there. So
You asked for a tough one.
it was a good one. So many dams no longer serve a valid purpose and they need to go. We're going to have dams in our rivers for a very long time because as a society through law, we have said you are allowed to put a dam in a river and generate electricity. That said, we have laws and all of the Clean Water Act through state and federal authorities requires that those hydropower dams are operated in a way that does not violate water quality standards. And there are strong standards in place for the states to impose conditions on the federal government. The job of nonprofits and advocates like American Rivers, Connecticut River Conservancy, and others is to ensure that those operating licenses for hydropower dams don't violate water quality standards. And that's a very challenging conversation. Yes, I have worked with state and federally recognized tribes on the questions of hydropower relicensing, both here as well as nationally. And Indigenous nations have an incredibly important role to play in not just saying this is how a dam should operate best, but recognizing tribal sovereignty and their indigenous relationship to those rivers and their indigenous and sovereign nation voice in these federal proceedings.
Okay, I have another question from Martha Roman. Martha says, I'm wondering with climate change and warming waters, if efforts to clean up our waters are being at least partially negated by climate change.
They are. That is a challenge. And so it is a function of changes in water temperature, but it is also a function of changes in flow. Climate change is here. It's been here for a long time. And more frequent, more intense rainfall events based on the volume and flow of that water is damaging to aquatic habitat. And yes, making our work harder. Absolutely.
Great.
Another example, like atmospheric or Clean Air Act regulation of mercury, the work to regulate Clean Air Act pollutants that are associated with climate change is incredibly important. And transitions to renewable energy and getting rid of atmospheric pollutants that are exacerbating climate change needs to happen because there's impacts all over, including to our rivers.
Okay, I've got a question from Chris Woodside. Could you clarify the situation with PFAS chemicals? Are these tracked in drinking water supplies routinely?
Yes, there are obligations for drinking water supplies to monitor for PFAS. And the example I gave in Vermont, those 17 drinking water supplies, because of monitoring, were deemed to be above those standards. And so therefore, those communities had to find other sources of drinking water. So yes, drinking water systems are paying very close attention to PFAS. How they resolve the problem, that's the bigger challenge with forever chemicals.
Okay, I think I've got two more here. Karen Hanscom asked, what can and will be done about the millions of gallons of wastewater, raw sewage that gets dumped into Connecticut River?
Good question. So the Clean Water Act requires that communities that have combined sewer systems, they are obligated to come up with a plan to not eliminate. Federal policy does not require the complete elimination of those overflow events. It requires that that plan be put in place so that the number of events and volume is brought to what the federal government has said is a minimal number. Practically, all communities in New England are working on this problem, and you can see many communities in the Connecticut River watershed, Chicopee, Hadley, and others that have completely eliminated CSOs. Other communities like Springfield, Holyoke, Hartford are spending a tremendous amount of money to resolve as best they can, given the limitations of the infrastructure, to either direct all of that rainfall to the wastewater treatment plant so that it is all treated and then discharged. That's a preferred solution. Or separating the pipes so that when it rains, that rainfall goes directly into our rivers. It's not an ideal solution because it still contains the bad stuff from parking lots and lawns and the like. So that separated stormwater is an issue for advocates, communities, states, and the federal government to put best management practices or green infrastructure in place so that when stormwater gets to our rivers, it actually has gone through a biological treatment or a green infrastructure treatment, and therefore the pollutants are removed before it goes into our rivers.
We have a little bit more time for a couple more questions. Give me just a second. They're flying in real quickly here.
Great.
Oh, Dave Armstrong asked, can you explain, or can the CWA be used to address the groundwater withdrawals?
Um, Depends on the state. Generally, no or sort of. So states do manage groundwater withdrawals in a couple of different ways. There are classifications of groundwater in terms of its quality. So Connecticut has classification standards for groundwater, which then assumes a protection level for them. Generally, though, it's state law, and state law tends to regulate groundwater withdrawals based on volumes. And frankly, much groundwater regulation is insufficient. It is simply you withdraw 50,000 gallons or more, you got to have a permit. And that permit may or may not relate to the withdrawals impact on an adjacent river system. Think about the Ipswich River in Massachusetts. So there is ongoing conversation and policy debate and advocacy around better regulation of groundwater withdrawals so that there is ecological basis for allowing withdrawals of certain volumes and type and in locations. So depends on the state, depends on the amount, and it's very much an open question whether we're doing the best we can. And I would argue, particularly in Massachusetts, there's a lot more we could be doing.
Well, a couple more here. At Vermont River Conservancy, Haley Colding asked, at Vermont River Conservancy, one of our priorities is to restore the sinuosity and floodplain connection of rivers that have historically been straightened, incised, and disconnected from natural wetlands and floodplains by human land use. Can you comment on these and other land conservation strategies that help restore water quality, physical characteristics, and biota? And thank you for your inspiring work.
I sure can. Go VRC. That's a whole other conversation. And yes, when we are doing ecological restoration of rivers and streams, and the example there, we've straightened them. Like, if we straighten the stream, we'll solve the flooding problem. Well, that's wrong. So yes, physical reconstruction of the way streams should function so that they have sinuosity, they access their floodplain is incredibly important for protecting communities from climate change and flooding, but it also improves ecological function for many, many critters and species. So it is a very valuable tool. It doesn't sit inside the Clean Water Act or water quality directly. And it is an amazing topic to explore. So I would offer Estuary, find some folks from VRC or others that are doing really cool aquatic restoration work like that.
Great challenge. Thank you. Let's see. James Bucock asked, has testing been done to monitor concentrations of 6-ppd chemical used in tire manufacture? Very detrimental to fish populations and potentially macroinvertebrates.
Good point. There has been, my understanding is there has been monitoring around the country to document that levels assessed in more laboratory conditions have adverse effects on aquatic life. And so let's take that right to the source. Junk tires, right? So the idea of removing tires from our rivers is going to remove one of the sources of that compound, which is having an impact on both at fish and those bugs. I know that the cleanup level in the Connecticut River, the source to sea cleanup, numbers every year, 500, 600, 700 tires every year. I know when I paddle frequently, main stem, there's not a day where I don't pass a tire in the river. Some of them with white walls that have been there for decades. Some of them been rolled down the bank just last year. So let's get tires out of our rivers and get out there on those cleanups and help solve that problem. It's a real one.
Wow. All right. I think we're at the end of our time limit. Andy, thank you so much on behalf of the Old Lyme Conservation Commission, Estuary Magazine, and the Watershed Fund. We're just very pleased with the material and discussion interaction tonight. There were some great questions. I'm sorry we didn't get to them all. Really appreciate the community support in this, and hopefully look forward to the next series of seminars coming up in April. Thanks so much.
Thank you. Appreciate the opportunity to talk with everyone tonight. It's an honor.
Yeah.